are in the research dome. This is our 36-inch telescope here. It's a big Cassegrain telescope. It's the largest telescope on the premises, and it's an extremely good telescope. It's a research grade telescope. This telescope has actually 3 refractors on it. Over here we have a little finder scope. It's a little 3-inch telescope. We have these other telescopes that have a much wider area that they can see in the sky in order to find the object that you wanted to locate. Right now we're using this 11-inch f14 refractor. It's as good of a telescope as can physically be made by man, and it's an excellent telescope, especially when you're looking at the moon and the planets and star clusters with. It really shines in those fields. We're on a floor, a platform that actually, an elevator platform that raises up so people can actually get up to the eyepiece here to look through it. Because small kids right now can't reach, I can't even reach it right now, so you know, we have to be able to get you up and down to it. And of course the dome overhead rotates around to follow the telescope when we move the telescope to a different part of the sky, so we can be able to look out in different, all throughout the sky with it. The telescope itself is automatically driven, so it tracks the objects in the sky. Once you put it on there, it stays there, and that way everybody doesn't have to keep fussing with it. You can go up to the eyepiece and just look in the eyepiece and see the object, and we move on.
I'm Jim. I'm in the East Dome. This dome is operated by the Fort Bend Astronomy Club. In the dome we have an 18-inch reflecting telescope. Reflecting telescope takes the light through the tube. There's a mirror in the back of the telescope, a curved mirror. That mirror reflects the light back to a single point up here in the front and then out the eyepiece. The diameter of the telescope is 18 inches. The focal length is 2,050 meters. So when you're working with a reflecting telescope or a telescope, the magnification is a function of the focal length of the primary mirror and the focal length of the eyepiece. In this case, we've got a focal length of 2,050 meters on the mirror and 27 millimeters in the eyepiece. So we have a magnification of, I don't know, roughly 70 or so times. We have this dome open every Saturday night for the public. Even on rainy nights, we can do some slideshow presentations off our computers. On clear nights, we have a very good telescope for looking at planets, at deep sky objects, at the moon. Just a good all-around telescope.
This is the West Dome out of the Georgia Observatory. The dome itself is a 14-foot dome, and inside it we house, it's called a C14 telescope. The primary mirror is 14 inches. It's a Cassegrain design so that we can have a short tube with the light path. It makes it a lot shorter. This telescope is also on an equatorial mount, so we can go ahead and put it on an object and it will track through the sky. So that way we don't have to keep moving it.
This is the old original analog positioning dials for the telescope, for the 36-inch telescope. We have the 3 here are called right ascension, and that's from east to west in 24 hours, 60 minutes, 60 seconds time. And then we have the bottom 3, which is called declination, and from 0, which is the equator, to 90 degrees is the North Star, in degrees, minutes, and seconds over on this. And everything in the sky has a grid coordination that we can find it with. Once we know the coordinates, these dials match those coordinates, and then the telescope would be looking at that particular object. Down on the below part here is all the controls for the lights, to move the dome around, to rotate the dome, to raise and lower the floor, and then the last one's over here to actually move the telescope itself to find the object with.